Hello, hi Andrea, hi May.
Hi.
Hi.
We are meeting today with Andrea Rossi, who is the creator of Wasp, a really great plugin for Grasshopper, for the ones that are not familiar with it. We really love the plugin. We used it ourselves on a couple of projects, and we're just wondering how more people can actually get to use it in their everyday architectural or design practice. So let's get started.
So Andrea, tell us a bit about yourself. We're just learning about where you studied and a bit about your work experience and your hobbies and so on. And what are you doing with yourself these days?
Yeah, so I am trained as an architect, so I studied architecture both in Italy, as we said, at Politecnico for my bachelor, and then I moved to Germany for my master, and I did my master at the Dessau Institute of Architecture, which is where I kind of really developed like a deep interest in computational design and, let's say, veered more and more towards software development. And right after graduating, I had this great experience of getting, I think, one of the most fun jobs I've ever had, which was being a robotic researcher at Computational in Vienna. So my job literally was, we had a small robot in the office and it was just figuring out what could be done with it. So, and then from there, I moved and I was for 1 year in Zurich at ETH, when I was working as a researcher for a large-scale urban planning simulation software. And then from there, I moved and I started my PhD, which is almost finished at TU Darmstadt in Germany again, and which is fundamentally based on Wasp. And let's say the main product of the PhD is Wasp itself. And right now, I am trying to finish my PhD still. And meanwhile, I'm a researcher at the University of Kassel, where I'm again focused on robotic fabrication, mostly using timber, and trying to develop sustainable construction methodologies, combining timber research, modular design, and robotic fabrication. And these days, specifically, I'm kind of taking advantage of the very weird situation we found ourselves with. And so thanks to remote teaching, I've been leading design studios both in Kassel and in Innsbruck, and as well as teaching small workshops and introduction as well in Berlin and in Darmstadt.
Awesome, sounds great.
Wow.
I think we have here material for a second podcast with the robotic experiment, especially. But yeah, let's keep it focused on Wasp for this.
Well, we were going to ask how you got into computational design and software development, but I think that pretty much covers. So it was your little robot that got you excited about this?
Yeah, so I think I already started in my bachelor. So I think at my second year of my bachelor, I had a design studio with Professor Attilio Nebuloni in Milan, who was like, I think, the first person that introduced me to, let's say, computational design, and also a whole wide range of architects and researchers, like ranging from Zaha Hadid to Tom Wiscombe, Hernan Diaz Alonso, and so on. And so there it was a very, let's say, strange experiment, because we had a lot of ideas and very little tools and very little knowledge of tools. So I remember modeling double curve geometries in AutoCAD 2007.
Oh, wow.
Which was kind of fun, but also very weird. But then from there, I started getting more in depth into it. And so my bachelor thesis was a, let's say, theoretical exploration of what computational design is and where it comes from. And so then from there, I moved to Germany, because I felt I wanted to do a master which would really focus on that.
Tell us a little bit, what's it like to develop your open source software?
It's a mess. No, in a sense that it's very exciting. And let's say the way in which it started, it was really, let's say I didn't start with the idea of developing an open source software in itself. I just started with my PhD and started developing some tools that would allow me to do the research I was interested to do on modular systems. And then kind of realized that, well, there was nothing out there that was allowing to do that. Or there were a few tools, but they were not really flexible. And so I released the first version of Wasp, which was like a really, really bad bunch of Grasshopper components that was incredibly slow and really didn't work so well. But then there was already interest for that. And so that kind of fueled me to work more on it. And so I'm very thankful to my PhD supervisor, Oliver Tessmann at TU Darmstadt, which gave me like a lot of space and time to develop Wasp and develop, let's say, the core framework of Wasp. And right now, as I said, it's a bit of a mess because I'm teaching in quite a few places, and most of the teaching I'm doing relies on Wasp, but in a very different way. So right now on my computer, there are, I think, 6 or 7 versions of Wasp, each of them doing slight different things that have been added. And I'm slowly bringing it back into the core Wasp that is available.
My goodness. Well, Andrea, the software industry has long ago adopted the open source mentality. The AEC field has a long way to go in that sense. What do you think about all this?
I think we really have a lot to learn. And I think it's going to be very hard for the architecture and the design professions to adopt the same workflow, mostly because I think we still rely a lot on a mentality that if we talk about the tools that we use to do something, we are kind of taking something away from the artistry of doing these things, so to say.
Take away the magic.
Exactly. And so I think it's very hard for the design professions to adopt that workflow. But I think it's the only way forward. I think that's a perfect example is the field of robotics right now. So there are, I don't know, many robotics plugins out there. And it feels that everyone is reinventing the wheel every time, which is fundamentally a waste of energy for everyone. And we have so many challenges in the whole industry that we should really try to focus the energies and try to share tools and reuse them as much as possible and grow as fast as we can, because it seems we don't have time and energies to waste.
That's a really good point. So Andrea, tell us a bit about the history and the idea behind Wasp.
So Wasp is, let's say, the whole concepts behind Wasp are borrowed from research that is done at the MIT Center for Bits and Atoms by the team of Neil Gershenfeld, which works on this idea of what they call digital materials, which is the idea of materials that are composed of discrete building blocks that then be combined in a discrete number of ways. And so the idea really behind it is to bring the capability that we have to program a computer to the real world, so that we would be able to program physical space by placing these discrete blocks. And so that was the idea, and that was also the idea where my PhD research started from. And so that's really a little bit how Wasp evolved. And so as I was saying before, the first version was a very, really patched up together set of components that would allow to do a few things. Again, relying on the power and the possibilities given by open source development. I was actually looking a lot into the structures that are used in the Ladybug plugin ecosystem. And there I was able to use a lot of their code templates and the workflow to highly improve the components and make them much better and much more usable. And so right now, Wasp has grown a lot, and especially over the last 6 months, since I've been using it a lot in teaching, I've been adding a lot of small functionalities that allow much more control over fine details of an aggregation.
So when you say the first version of Wasp, do you mean the one that everybody's using, the one that's on?
No, there's one before that.
Okay.
One before. There's 0.1.0 that it's nowhere to be found anymore because I'm a bit ashamed of it.
Okay. Because you've been developing is it 0.0 or it's 2? more, but
Sorry?
there is a lot going on GitHub for the latest version, but I don't think it's still uploaded on.
No, it's not exactly because of what I was saying before. So right now I'm focused on features development. So adding more and more features, but this is creating more and more problems in the backend, which right now I'm managing to not make explode. But so I would actually like to address some of those before publishing a stable release, because some of the new features that I published, they don't all work together right now.
I see. Yeah, we actually played around quite a lot with the first version that is on foot for Rhino, and also with the beta version. I sent you a couple of emails. Had some issues, but yeah, the beta version seems very powerful.
Yeah, a big development of that came from the design studio I'm teaching in Innsbruck at the moment, which I'm teaching together with Sajay Bhushan from Zahadid and Johannes Megens from Incremental 3D. And we are doing 3D station, three railway stations. And so there was a huge demand there for highly increasing the capability of controlling and aggregation, and particularly all the local relationship between the parts, so that we didn't have parts of a train station that fly, or also things that are connected in a specific way. And so that was like a big push into making things much more controlled, and so adding all these new features, some new constraints, and so on. I think a lot of the effort that went into Wasp recently is that, let's say, Wasp was built with the idea of creating aggregations of thousands of parts at the beginning. So that was the first work I've done. And right now, more and more, the work I'm putting into it is to kind of go much more in detail. And then if you want to also get closer to, let's say, real architecture and construction, you are going to be most likely working with 50 units, 20 units, maybe 100 units. And so that's a lot of the effort which I'm putting in right now. Is less large-scale aggregations and more detail and control over how they work.
Yeah. Well, we actually tried to aggregate modules, limited number of volumetric modules. Then just picking from the catalog the configurations that we liked, restraining the aggregation in this, and then also having the ability of the smart attributes, which give you the possibility to directly generate, let's say, a geometry that is good for Karamba or Ladybug. So that, I think that is really powerful, because you're creating an aggregation which is purely design or architectural, but then you can also create aggregations that are for analytical structural model or environmental model, and then you can actually sort these aggregations, classify them, find the best one. I think there is a huge potential, I think, in that direction, probably for Wasp.
Yeah, that's really, I mean, at the core, the way in which I see Wasp is fundamentally it's providing a data structure to represent these combinatorial models. And so the idea is that you could then use that data structure to attach anything you might want. And so you can really carry this model around across your whole workflow. And then as you go, add information to it.
Yeah.
With this idea of having a much more parallel design process, so where you have multiple phases that could run in parallel, and then you could just change the modules and know that everything else along the way will adapt, which is a bit different than much more traditional architectural approaches, where if you change something in a later phase, you kind of have to go back and re-update everything all the way.
Andrea, it seems that you don't advise users to use evolutionary solvers much in conjunction with Wasp. We were just wondering, are you planning on adding this sort of functionality to it as well further down the track?
Well, that's kind of complicated as a approach. So the main reason why I mean, it's not that I'm not recommending it, it's just that I believe that, let's say, for the current state of Wasp right now, everything that users can do is change the, for example, seed of a random, of a stochastic aggregation, in order to iterate through different results. The problem is that since it's purely a random seed, there is no relationship between, let's say, one number and the following one.
Yeah.
And so what that means is that an evolutionary solver will assume that if the seed set at 2 provides a good result and the seed set at 4 provides a good result, most likely the seed set at 3 will also provide a good result. And that's actually not the case because it's a purely stochastic process. So in order to be able to do to run an evolutionary solver consistently on Wasp, what the evolutionary solver should be able to do is to control the aggregation graph itself. So if you would have an aggregation of 100 parts, these 100 parts and how they've been placed would become the genome that the solver would manipulate. And that's quite difficult to implement because it's probably quite different for different kinds of aggregations. So I'm also personally not an evolutionary optimization expert. And so I believe it's not impossible, but it's not easy in a way. So what I'm planning to do, I don't know when, but in the future is to make the API of Wasp much more open and much more accessible, so that rather than just relying on the components themselves, users could use Wasp as a library in their own Python components. And that could probably then enable somebody that has more experience than me in evolutionary optimization to maybe write something that would run optimizations onto the aggregation process itself. Like, I'm not saying that it's not possible to do that or it's not relevant. The only thing is, for how it's built right now, Wasp, it would be more efficient to just take the slider and put it in the seed input and just move it from 0 to 1000 and record all the steps and sort them.
Yeah.
So that would just be more efficient than having an evolutionary solver, because since there is no logic underlying that.
Yeah.
So
yeah, I guess
that's currently.
For if you have one, let's say, if you have one criteria, but if you have, let's say, 3 criteria and you're trying to find the best solution between the 3 of them, I guess what was in our tests, was kind of useful in that sense.
Okay, yeah. I mean, okay, yeah. If you use say then yeah, of course, then yes, because it's more about categorizing the outputs rather than the solver itself. Yeah, then that makes sense. Yeah, definitely.
Exactly. Yeah.
Andrea, what are your plans and ambitions for Wasp? Is there a master plan?
No, there is no clear master plan. There is the will of continuing to bring Wasp forward. And so that's exactly something that I'm addressing right now. And I'm going to pretty soon launch a Patreon page to support the development of Wasp, because I see that, I mean, right now I'm very lucky that I have the possibility of working with academic institutions that are willing to allow me to reserve part of my time to develop Wasp, also because it's involved in the research I'm doing. But I just don't know if that's always going to be the case. And so I would really like to find more of a way of sustaining Wasp as a project in itself. And so that's a little bit the goal. And in terms of long-term plans, so one hopefully not too long-term plan is to definitely rewrite all the internal engine, because right now it's really struggling to cope with all the new functions. And so it would really need to a significant cleanup. And then, as I mentioned already, the idea of making the API more open and accessible and better documented. And then definitely the idea of starting to look at the possibility of porting Wasp to other environments rather than Rhino and Grasshopper.
Yeah. Have you tried, I'm testing currently Wasp with Rhino inside Revit.
I haven't yet.
No, okay, I'll let you know.
Yeah, that would be curious. Yeah. But yeah, definitely having the possibility of running Wasp. The 2 environments which I'm interested in are, of course, Revit, and the other one is Blender, as it would allow the project to be really completely open source.
Yeah. Yeah, of course. Blender is great in that sense.
Mm-hmm.
Andrea, you mentioned that sort of how you started off on this quest, but now are you driving this project mostly on user requests? And do you have any idea how many users are out there on Wasp?
So I can't really say how many active users are there. I know that there are around 6,000 users that downloaded it on Food for Rhino, more or less 6,000 unique users. And I think there are around nearly 400 users currently in the Discord community. So I guess the number of users sits somewhere in between those two numbers. And one of the very interesting things that happened with Wasp was that there are 2-3 projects that emerged out of Wasp. And one of them is, for example, the Wasp++ plugin. That is a plugin that has a few features that were not available in Wasp, which was developed by Blake Hageman. And I don't know Blake. I never met Blake. I never really talked to Blake. And I even had no idea that, like, I got somebody writing me, hey, there's a Wasp++ plugin. And I was like, nice. And for example, that's one. Another project is the Disco VR environment, which is an environment developed by Jan-Philipp Drude in Hanover, which is an environment for aggregating Wasp in virtual reality, which is also entirely free and open source to download, and which we've been working together on. And we are also going to run a workshop at the next AAG conference on that. And then, as well as a project at the University of Applied Arts in Vienna, which is called Conceptual Joining, which was developed by 2 ex-colleagues of mine from Coop Himmelblau, who also took Wasp and added few functionalities for a project that they were developing. And then from there, we started collaborating. So I don't see that, at least that's my hope, that I don't necessarily see Wasp as entirely bound to me working on it. So I really hope, and that's actually the big goal of improving documentation and improving the API, because that would really make it easier for somebody to pick it up and work on it.
Mm-hmm. Yeah, actually, we also downloaded Wasp++. As far as I gathered, it's based on Rabbit, or at least there are some, there is this plugin Rabbit, if I'm not mistaken, that has this component Turtle as well. So, but it's a bit hard to work with Wasp++. At least there is not much info on.
I mean, I think it's something very specific and developed for some very specific project that they've been working on at the Illinois Institute of Technology. But again, I really appreciate that somebody does that I'm working on a project, I develop some extra components, and then I'm just going to put them out there and people can use it. And then it's up to people to see if they can use it. Maybe they can learn something from it and they can add those functionalities. Some of the new functionalities that are in Wasp are actually inspired what Wasp++ allowed to do.
Andrea, I must take a considerable amount of your time to have developed Wasp. Really great job, and kudos from all the users of Wasp. In our own experiments, we've seen that there's a huge potential to incorporate Wasp in modular studies. What's your take on this?
Well, that's really that was a little bit the goal. As I was saying before, it started more with this interest into very large aggregations, but right now I really see it more and more to getting closer to modular construction and allowing more and more to really explore the possibility of building with modular systems in a way that is not as bound by conventional and predefined forms as more, let's say, conventional construction modular approaches allow. So it's this idea of trying through a software to push a different idea of what modular construction is, and also in a way push away the idea that modular construction is, let's say, modernist concrete buildings which have zero differentiation. But really look at the possibilities that modular construction has an incredible amount of advantages compared to on-site construction. And so really try to see if we can marry those advantages with high quality design.
And could we expect Wasp for other software other than Grasshopper as somewhere down the pipeline?
Yeah, I mentioned it already. There is, so these two environments I'm interested on is definitely, one is Blender and the other one is Revit. And Blender has the advantage of being Python based, and so should make it not too hard to move Wasp there. And then the other one is, of course, Revit. I've been involved as well with the team of Compass, which is a computational design framework developed at ETH Zurich by the Block Research Group and now also by the Gramazio Coder Group. And that was the idea of bringing Wasp onto their platform so that then the Compass platform would serve as the translator between different softwares. However, when I tried to do that, and it was nearly 2 years ago now, it was still a bit difficult, as Wasp requires quite a lot of iterative computation, of testing collisions, and that was not really working well with Compass in terms of performance. But I've just seen that they recently released the 1.0 version of Compass, and so that might be a direction in which Wasp might go, so to integrate on top of the Compass framework.
Okay, what about the other BIM softwares? I guess Revit is always the first, but
yeah, I mean, I'm honestly not a BIM expert in any way.
Yeah.
So I'm a little bit too far from architecture practice since a bit too long.
Yeah.
So, but if you have some suggestions, that's definitely.
Oh, I mean, I think when the ArchiCAD and Vectorworks users hear that, you're creating a plugin for Revit, I guess it's always like, there are users of all of these three software. I think they're quite popular in various countries.
Yeah.
Depending where you.
I mean, I think it's, for me, the problem independently of the software, so Revit, being Revit, ArchiCAD, Vectorworks, or anything else, is the fact that right now Wasp is taught as a pure geometry engine. And so I think the big question is to understand how can Wasp be implemented into the different BIM classes and how that it would deal with those. So I think that's, for me, the main question, which I also have because, as I said, I'm not a BIM expert in any way.
Yeah.
So I think addressing that would be, let's say, the main challenge of how to organize a tool on top of a BIM framework.
Yeah. Yeah, I guess, yeah, that's the main difference, like really how it's been structured within the software, in terms of categories and so on. But I guess now having Rhino inside, I imagine that would be a lot easier now, because I think it's still under development. I mean, as far as I know, like it's been constantly improved, but I think a lot of the challenges you would face otherwise, like now with Rhino inside, will be easier for you.
Yeah, it's always a little bit of a question that is there for Wasp, in like for how the backend of Wasp is organized, because right now the whole backend of Wasp relies on Rhino Common heavily for all the geometry operations. And one of the ideas that I have is to build an intermediate layer that would be, let's say, a Wasp native geometry library that could then be configured to Wasp to work with different geometry kernels. So then, let's say the Wasp library would never change.
Yeah.
And would just deal with these Wasp geometry types. And then these Wasp geometry types would have the task of interfacing with the Blender geometry types, the Rhino geometry types, the Revit geometry types.
Andrea, how do you feel about the blending of architecture and software engineering? Do you think at some point our industry will merge with the software industry?
I don't think it will merge, but I think it's very much needed that as architects, we engage more with the software industry. So the reality is that right now, as architects and designers, we are mostly working with softwares that were not made for us. So we're working with softwares that were made for something else and then just been repurposed for architecture. And so I really believe that as architects, we should really take the responsibility of engaging much more with the software industry. And what's funny is that if you look at the history of the relationship between architecture and software, in the very early stages, architects were driving the software industry in a sense. So if you look at figures like Christopher Alexander or Richard Saul Wurman and so on, you can really see that they were architects that pushed the software industry to a new level. And what's very interesting is that they're much more recognized in the software industry than in architecture. So if you talk about Christopher Alexander, a lot of people will have problem with him when you talk about architecture. But if you talk about Alexander and the whole idea of pattern languages in computer science, it's an acknowledged way of working. And it was a revolutionary approach to how to do programming. So I think we have to go back to that approach where as architects, we push the software industry in a direction that we think it's relevant for us, rather than always being fed with tools that don't really work for what we want to do.
I very much agree with what you're saying, but I think it's even more so like this kind of proactive approach from architects should be happening even more so with all the robotization that is inevitably also going to happen. And as for example, in 3D printing, like knowing the tool well, like being able to even come up with design suggestions based on the tool, you know, like any sort of craftsmanship is important, because I imagine these huge 3D printers or like robots or I'm not sure how they would look, but if the architect is controlling them in a way, then this becomes also part of your design. So it's intentional, like everything will be intentional, which eventually will hopefully lead to better design decisions. And
yeah, definitely. And also I think the more we engage and the more we can create things which are much more integrated with architecture. I think a fantastic example is the Mini Builders project that was done at Institute of Advanced Architecture in Barcelona a few years ago, where the researchers and the students really questioned the idea of what is a robot that can print something in concrete. And so instead of using a gigantic robot arm, they made teeny tiny robots that could just go around and print on top of a concrete structure and just make that. And I think we need more of that. We need to challenge what is a robot, what is a software, what is CAD, and really bring in the needs we have. But it's hard. I mean, it's hard.
IAC is exactly the Institute of Advanced Architecture, and Barcelona is exactly one of those places that certainly
definitely,
you know, pushes the industry in that sort of a new mentality as well.
Yeah, exactly.
Andrea, what do you think will be the place of the architect in the future landscape of AEC?
Well, I think it relates to the previous question. I think if we will engage with software and with robotic tools and with all the technology that drives architecture, I think architects will have a central role and should have a central role. But if we are not doing that, and I think that it's to some extent already happening today, we are risking more and more to be pushed to a corner. And so we are really risking to go back to the Beaux-Arts environment where engineers define everything and then call architects to put the decorations on the facade. And I mean, it's a bit harsh maybe to say that, but I really think that technology is advancing at such a pace. And now also with the whole pressure driven by climate change, it's the adoption to technology is speeding up so much that if, as architects, we don't engage with it, we are really risking to lose our capability of driving this process.
Yeah.
What's your favorite computational design project that you can think of?
So as
There must be a few to choose from.
Yeah, but as I mentioned before, as I was saying, that I believe that the golden age of computation and architecture is quite a few years back. I really think that some of the best projects, computational design projects, are not necessarily computational in a traditional sense, but are some of the work of Cedric Price, particularly something like the Fun Palace or the Generator project. And I really like those projects because they are projects where computation and artificial intelligence, if you want to call it, we're not simply a tool to generate architecture, but we're something that we're deeply embedded into the structure of architecture. And so like software and digital processes became a material of architecture themselves. And so buildings would be able to respond to the needs of the user. And if I would have to think about something built rather than just theoretical projects, I think something that comes closer to that is some of the installations from Philip Beasley. So the Ilozoic ground installations, where as a user, you're immersed in an environment that is at the same time physical and digital, and it's able to interact with you. And I really think we need more of that.
Awesome, great. I think there is a lot more we can talk about, but I think that was a great session. Perhaps we can schedule a next interview more on the topic of robotics. But thank you so much for your time, Andrea. It was lovely to have you today.
It was great to talk to you. And I'm so happy that you are taking and making the effort of promoting open source in architecture more. Because I think that's really something that we need a lot.
Yeah, I think so too. And all those people like yourself also deserve some attention as well as a platform to hear about them, and like just to get even appraisal for the great job that you're doing. So guys, can I ask you to have one selfie? Like
Lovely to meet you. Keep up the good work, man.
Thanks.